recording. Okay, so my name is Lucio Simoni. I'm the engineering manager for BC Group. And in this session here, we're going to be demonstrating the ESU 2350. We can see that here. And we're particularly going to be doing a PM procedure on the FT10, which is on the right here. So I've got a couple of screens here. It may look a little busy, but this is the best way to actually see everything. So up on the top left, we'll just go through the screens here. On the top left is the actual front panel of the ESU 2400. So I'm actually going to be interacting with a remote application called CER host that allows me to run the 2350 through the network. It's great for demonstrations like this. So I don't have to reach across and press buttons all the way on the 2400 or 2350. I can do it right here. The next screen over is the Force Triad, or sorry, FT10. I'm used to doing these for the Force Triad. So this is my FT10 screen. So I will be interacting with that. I'll try to use a stylus as much as possible so you can actually see what I'm pointing at. And then down below that, we have a video of everything. So we can see all of the cables here. This is the standard accessory kit that comes with the 2350, with one exception. That's this guy here. This is the BC20-0305. No, sorry. I'm going to get the number wrong. I've got it actually here somewhere. But this is the monopolar foot switch adapter. Yeah, BC20-03050. Now, the reason this is needed is because it plugs into the foot switch port on the FT10. If we don't have that, you can see that the size of the connections are grossly different here between the banana jack that comes with the cables and the 4mm pin for the foot switch port. So we're going to plug that guy in. I'm just going to leave him there. And that's how we're going to connect monopolar 1. Okay, some of the features on the 2350, just to give you a brief overview. This is really a merge of a couple of technologies. One is the ESU 2300. And so we'll see these connections on the front panel are identical to the ESU 2300, the same way they function. If you've used that before, if you're familiar with that, then the operation of this unit will be very easy for you to pick up. If you're familiar with the ESU 2400, the main difference here between the two is automation. So with the 2350 and the 2300, you have to manually connect to the load path, to the circuit path, where the 2400 does that automatically. So when you're doing a REM test, or you're doing leakage, or you're doing that kind of thing, it automatically rearranges the load inside the unit. So in this way, we have to manually connect things. But if you're familiar with the ESU 2400, then you'll be familiar with the user interface. So these are the same 6 buttons that you would see on the 2400. And so I'm just going to go over a few brief introductions here. This is your main screen when you turn it on. If you hit the title, it'll give you all of your firmware and software versions, tell you when your calibration is due, all that good stuff. And then the main function that you'll do when it's visible, let's see, it looks like this is a little too low on the screen. Let me pull this up a little bit. Actually, what I'm going to do is send this video down. There we go. It's okay if we overlap the top of it. So now we can see the full ESU 2350 screen, which is more important. We went in to measure RF energy, and this is the screen that we'll get. Just going across the top, we can place a hold to hold the measurements. We can go into the test setup and select which mode, what are we connected to, how are we What output are we testing for monopolar? It shows me right here. Here's all the connections I need to do if I just want to do a standard test. Again, if I want to do bipolar, how do I connect this thing for bipolar? Shows me my connections right here. That's where we put the connections, and then we'll get a measurement. The display parameters. So we have programmable display up to all the readings that we can measure. You can see it all at once. If that's too busy for you, if you really don't want all that information, you can display 2 measurements or any combination thereof. The fast averaging here, so we have slow, medium, and fast, and that really that's just like your multimeter. You can put it in fast, medium, or slow measurement mode. The fast gives you a quicker response, but it may be more bouncy. The slow takes a while to give you a stable reading, but it doesn't move at all. And for the most part, with this 2350, you can leave it in fast or medium, and the measurement won't bounce around too much for you. It'll be nice and steady. Down in the bottom row here, we've got our foot switch. So this actually activates the foot switch output here, allowing you to trigger your generator. And then we can select which output we want to use, how long we want it to be active, and then when we hit that button, it will activate that meant to interface between our foot switch output port and your generator for the Force FX, Force Triad, FT10, that sort of thing, ConMed. There's a bunch out there. The other thing that's important here is isolator to ground reference. Now, I don't have an example here, but if you're testing a bifurcator, those outputs they don't always use a return electrode. So they actually use the patient table to a path to earth ground to return the current. So in that case, if we look at the test setup, the power comes into the active port through the load, through the REM to earth ground. And so you would have to use one of these jumpers here. Again, the 2350 does not have the automatic switching like the 2400 does. So you manually place a jumper here for the return electrode to earth ground, and you get your measurement. So, and then the test load. This is how you configure the load. Just like the 2400 and 2300, you can select the internal loads or the external or a combination thereof. So in this case, if I try and pick 11 ohms, we have to be a multiple of 5. So that is one difference between the 2400 and the 2350. Our loads are limited by 5 ohms, which in most cases isn't a problem. And that's what we'll see here as we test our FT10. Okay, so that's the main screen. Also, as I have 2 readings on the screen, I can pick whichever measurement I want for those 2 readings. So just to let you know, that's an option. And go back to one reading, milliamps or watts, whatever. So we go back to the main screen. That's the measure RF energy. The other thing that we would do on a routine day-to-day basis, just manual testing, is leakage. And so we'll see the screen is the same interface, but we change the button to green just to kind of indicate you're doing earth leakage testing. And also our setup pictures change. It shows us how to do connections for all of these testing. Now we've given these names, leakage 1A, 1B, 2, and 3. Those match the ESU 2400 nomenclature. So if you're used to that terminology, you'll see the same thing here. Again, the connections just have to be done manually. So leakage mode A, leakage 1B. This is testing the return electrode. So it looks a little strange because we've got a blue cable going to the yellow terminal, but the cables, color's just a color. The main thing is that you take the return electrode of the generator to the active input, and we're measuring that current to ground. So we try to make this interface as user-friendly as possible. It tells you exactly how to configure the unit for all the testing that you need to do. And the user manual gives better descriptions than what I can do verbally here. But anyway, those are all the leakage modes. It shows you how to set them up, that sort of thing. And we'll run through the testing here, and it'll show us all of those modes that we need to. The REM test, that's measuring the return electrode monitor. REM, ARM, CQM, different manufacturers call them different things. But the main thing to note here is that we have two cables that come with the 2300. And most generators identify, I'm trying to get this in a good visual spot here. Most generators identify whether you have a split or a single pad based on this pin. So the pin that's here, that identifies that you have a split pad, and the generator then measures the resistance between the electrodes to make sure that it's valid. Now, the Covidien FT10 and the Force Triad, they always use split pads. They don't allow you to use a single pad. So that makes it easy for that testing. In this mode, we can set a resistance. And then we have a lot of the tests that you'll see. They tell you, adjust the resistance slowly, increase it to 135, 140 ohms. Indicate when the alarm triggers or when the alarm goes away. And so we can do that easily here. We can step by 5 ohms. And now in this is a different load. And also it is here across the CQM. In this case, it is in single ohms. So we have a separate load bank than our power load. So we can adjust by a percentage. We can increase by 50%. A lot of the service manuals say if your resistance goes up 20 or 30%, you should get an alarm. So it makes it easy to test that. We also have an automatic mode where it will just ramp up the output at this speed, and then you can stop it when your generator triggers an alarm. So that's kind of handy as well. Okay, so those are the main manual testing features. But the purpose of this demonstration here, the main meat here, is how do we do the PM procedure? So if you've been involved in that, it can be pretty lengthy through the service manual. So what we've done is we've generated a auto sequence that allows you to follow the step-by-step procedure. You do all of the testing for the FT10 with none of the hassle. So we'll go ahead and open this up. Now we'll see here's all of my steps. We can do a preview if we want, but essentially we just go up here to start. And now we can enter information about our device under test. So if we have a barcode scanner, we can plug that into the USB port on the side of the 2350, and I can scan my barcode that's got my ID number, manufacturer information, model, all that can be in there. Kind of cute thing here. So if we want to sign this, we can do a signature on the screen, and that will then be saved into my report. Just proof of who did the testing. So then we put all of the information in. Now we're going to start our test. Now what we'll see here is if we do this and we don't enter that information, it just leaves blanks up the top of the report. So we can fill that in later, write it in manually, or we can enter that information and have it as part of the report. So just like the service manual, this auto sequence will guide you through all of the inspections. So we have to check all the ports, we have to check the switches. So, of course, we've got our legal disclaimer here. What good automation wouldn't be the same without a good legal disclaimer. So if you have any trouble sleeping, this is a good one to read all the way through. But really, it's just make sure you have everything, you're ready to go before testing. So I encourage everyone to read that in depth. Then we get into the actual inspections. So the first we have to do all of the as we read the instructions, required equipment. We have to make sure we have everything we need. So this is based on the service manual. This is what Covidien tells you need in order to test the generator. You need all the pencils, you need the foot switch, you need all this other stuff. In this case, we added the foot switch port adapter. You do need that for this testing. And then everything else is specified by the service manual. We do have the safety analyzer SA 2005 listed or higher. That's for doing the low frequency testing, and we'll get to that at the end. Even though the 2350 can't perform those tests, it can still guide you through that process of how to do that. So, and then this is giving us information about the auto sequence, telling us how it's going to work, how to use the auto sequence. But you have me, so we don't need to read that right now. We're going to advance there. Okay, so rear panel inspection. Now we're getting into the meat of the PM. So you're going to check all the foot pedal receptacles, make sure there's no broken pins, make sure all the contacts are good, all the cables are okay, that sort of thing. And again, there's really nothing for the 2350 to do other than tell you what to do and make sure you do it. Now I can try and advance through the test without doing this step, but I can't. It says it either has to pass or fail. You cannot get to the end of the test without selecting one or the other. So in this case, I did my inspection, reading my instructions carefully. But you don't want to watch that. So take my word for it, it passed the power on self-test. And if it does power on, you should see 4 quadrants, all that good stuff. Yep, that's true. We're good. This interlink cable does, but anyway, plug it in, make sure it works. Say that's good. Check monopolar 1, monopolar 2, make sure there's no obstructions, nothing blocking, no broken pins. More physical inspections. Essentially just follow the guidance of what's written here. And we'll say we did that. Check the return electrode. Yep, we're good. Lots of inspections. And again, these come straight from the service manual. So this isn't our verbiage, this is theirs. So we follow that. Yep, foot pedal inspection. We'll just, yep, we inspected the foot pedal. Verifying the audio, so we can go into audio. Oh yeah, audio works. Okay, so now, again, giving the operator the instructions they need to perform the test. Now we have to get into the output mode. And again, this is based on the service manual for the FT10. So we go into service, we hit OK, and I said I was going to use a stylus and I didn't do that, sorry. So we go into service and we put in our magic code, if it behaves, 423213. Which is in the service manual, and now we're here. And we go to RF output test. This is where we're going to do, this is really the main interface on the FT10. We're going to do everything from here. So my instructions are right here on my screen. What do I do? First, set up the FT10. So we're going to go to spray, and we want monopolar 1, and we want 120 watts. So easy thing there is that's the maximum output. And then it's going to tell me how do I do my connections. So yellow cable going from the left tine of the monopolar 1. So here's monopolar 1, here's the leftmost connection, and that's going to go to active on the 2350. And then we're going to take our dispersive cable, and in this case, it's probably going to yell at me because I'm going to use the one without the pin, but the FT10 requires REM. And that's why we go into this special test mode, because that allows us to bypass it. Now in clinical mode from the normal main screen, it'll yell at you if you try and use this cable and if you don't have a good pin. So we've got our connections. It said active to the leftmost tine, connect the REM cable, and now it's telling me activate the FT10. So that's this button here. First I'm going to do show meter. Now this is in measurement mode, so it's live. It's taking readings, and I hit active. I've got my reading. I hit capture and deactivate. So now it stored my reading. It analyzed it, and it said it was good. So inside this auto sequence are built the limits for the test. So it knows whether it has to be within a current range. I don't know what it is specifically for this one, but if the measured current isn't within range, it'll show you that it fails. Now we go on to the next step, and it says pure. So we're going to go in here, pure, and it tells me a power. We want monopolar 2. It tells me 10 watts. So we don't want to go too far like that. That would be bad. What happens when you're not paying attention. That's how you can fail a test, is by running the power way too high. So connect the yellow from the left line of monopolar 2. And connect the REM is still connected, so we're good there. And then activate the generator. So I'm going to show my meter, activate. Now it's saying, are you sure you have the right cable plugged in? Yep. Thank you very much. Get my output, and it's good. Now what happens if I forget to deactivate the generator and I say, okay, let's just move on? Oh, power's detected. So deactivate your power, and then it will allow you to move on. So it's trying to safeguard itself from trying to switch loads while the power is active. And that's the 2350. So it knew there was current there, and it's like, I'm not going to move on until you deactivate the generator like I told you to. So then we go in here, pure, monopolar 2, 300 watts. So the nice thing here, I get my settings for the generator. I get my wire to the test. So go to show meter, activate the output, capture the reading, deactivate, move on to the next. Now we go to blend. So if you notice in the service manual, they have you test, we're going to test every port and just about every setting, not every setting, but every mode on this generator. And what they're doing is, just making sure that all of the modes work, all of the ports work, different power levels, that sort of thing. And so we're just going to walk through this process here, capture, deactivate, and move on to the next. Now you'll notice also this load, it's set, that's all pre-programmed into the auto sequence. The 2350 automatically sets itself to the load that's required per the service manual from Covidien. So now we go to Valley Lab mode. Now these aren't alphabetical, so sometimes you got to kind of hunt for which output you're looking for. But in this case, we found it fairly easily, 75 watts. Again, we're still monopolar 2, so we're good to go with our connections. Show meter, activate, confirm you want to activate. I really do. I did push that button. Okay, we got a meeting, got a measurement. We move on. Fulgurate now. And 30 watts. So different power levels, different waveforms, same connection, so I don't have to move anything. Do a capture, deactivate. So this time we're at 500 ohms. Now I'm going to try and set this one intentionally wrong. Oh, let's just do this. We'll go to spray. What happens if I do this wrong here? Monopolar 2, it says 10 watts. Yep, I set it to 10, right? So then I go in here, show meter. Sure, activate the output. Thank you very much. I hit capture. Oh, that's a fail. So the first thing when I see a fail, I'm thinking, oh, well, this thing's, it's bad. It needs to be serviced. Well, first things first, let's go in and measure. Do I actually have everything set up right? Oh, I missed this. I got off by a factor of 10. So I can go in and fix this. Now, when I go back to my meter screen, I've got a measurement here. Now what do I do? Well, I can go up here and I hit new capture because I want to remeasure this. and I activate it. And I take a new capture. Oh, it liked that one. So we're good. Now we can go on to the next. Okay. Now up at the top, we have a list of steps and it's showing us exactly how far we are in the process. So that's always nice to have. So I'm going to go to the right output, which was spray. Yeah, I did the last one in shared spray and it still took it. I guess spray and shared spray are somewhat the same. Good question for Covidien. Okay, so then we have the same connections. Show meter, activate, capture, and we go on to the next. So again, we're doing different output modes. It helps when you push the right button. Soft coag, mono 2, 120 watts. They do a lot of maximum power testing, you'll see, especially when doing leakage because you're looking for a worst case scenario. So we activate the generator, get our measurement, move on to the next. So you can see as you get used to this and you do this a couple of times, it gets pretty easy. You can go pretty quickly through this, especially if you remember where the output settings are, whether they're at the top of the list or the bottom of the list. Mono 2, 50 watts, activate. Now, the reason we have to do all this manual setting, if you've ever done the force triad auto sequence on the 2400, you'll notice that it's completely automated. You plug in an RS-232 cable. Now, I'm dangerous here. I'm talking and trying to do this at the same time. This is when I make mistakes. So the ESU 2400 and the force triad has a communication cable, and we worked with Covidien to develop that auto sequence and the communications to the force triad. And so when they developed the FT10, we said, hey, it'd really be a good idea if we do those auto sequence again. Can we talk to the, oh, now we're doing bipolar. Can we talk to the FT10? And they say, absolutely not. And they haven't budged. So I don't know what it would take to get that to change, but we cannot no longer connect automatically, set the output of the FT10 and trigger it and all that good stuff like we do with the force triad. So I apologize for that. Everything has to be done manually through this interface on the FT10. Okay, so now we're going to do bipolar, and I'm going to see if I can find it. Bipolar macro, FX macro, nonetheless. On the bipolar port, it automatically found that for me. And so again, now we have to change things because we're testing bipolar. Connect the yellow from the left time of the bipolar. We're on the left side. And then we have a blue test lead and you can go to either dispersive port, doesn't matter. And we plug that into the right time. And now we've got everything set up, 95 watts, bipolar connections, activate, and capture. It liked that, so it's going to let us go on. Again, note that the measurement updates, the test load updates, sets that exactly what it needs to. That's one thing I don't have to worry about is the test load. Bipolar FX standard, 35 watts. Okay. Now, one thing, I mentioned the different averaging modes. Now, this is set to medium averaging. Because I'm running an auto sequence, I can't change that. But if I do have any questions about the test setup, in this case, I'm doing bipolar, it does show me, here's how you do your bipolar connections. Now, this one says connect to the top of the blue. I'll just show you. It really doesn't change anything. Those are shorted internally. So we go to capture, and let's see. I wanted to show you the medium averaging. So I'm going to activate the generator. and there's our reading. That's medium averaging. It's really not moving around very much. It's a nice, good, stable reading. So we can capture that. And that's why I say you can use medium or fast. Fast pretty much works with everything on this this particular analog circuit that is in the 2350. So FX precise. I apologize if I'm rambling a little too much. Just trying to give you as much background information as possible while running this test for you. So we activate there, we go here, we got our reading, and we move on to the next. Ligature. Okay, so how do we, that's one question I get. How do we test ligature? Well, number one, you want to be in this test mode, and you want to push on the right button correctly. And 5 watts. So ligature is just like bipolar. As far as the 2350 is concerned, it doesn't know the difference. It's just measuring a signal. So we follow the connections here, active to the left tine, blue to the right tine. Does it really matter if I reverse these? No. But this, for consistency, we just do it this way. So we got 5 watts, we activate, and we capture, deactivate. This time we're at 50 ohms. Ligature BPR. That one is somewhere else. I thought it was at the bottom, but I thought wrong. Oh no, RF mode. Sorry. RF mode is ligature. I was in the right one. And the channel is BPR. Power setting 350 watts. This is the only Covidien output that is higher than 300 watts. At least that I know of. So 350 watts, yellow to the left, blue to the right. Activate and measure. Capture that. 2200 milliamps, or 2.2 amps if you like. Okay, so then we do effect 6. This is the one I was thinking of. BPR coag. BPR coag. And effect 6 on the ligature port. And yellow to left, blue to right. Just confirm our connections. Activate, capture, deactivate. We move on. BPR cut. Effect 6. And yellow to left, blue to right. Show meter. Now you'll see the number bounced around a little bit. So that's the internal, the analog circuit doing its thing. It's auto ranging, getting the most accurate input to the A to D converter based on the reading that's coming in. So you want to wait for it to stabilize, but once it does stabilize, it's pretty solid. Cardioblate bipolar and 50 watts. Yellow to left, blue to right. That's a nice little tone. Capture. It's okay. I'll do this on the next one. That's good. Let's do this. So Cardiobate 100. So 100 watts. So in this case, what happens if I'm trying to show you some of the errors, some oopsies that might happen. So I deactivate the generator. Oh, I didn't capture it. Well, I can try and capture it now and it's going to fail because that's outside of the tolerance. So I can hit new capture again. All I got to do is reactivate the generator. So in this screen where it's at right now, it's a multimeter. So it's continuously measuring the input. I don't have to worry about synchronizing, activating the generator and all this stuff. It's just reading. Whenever I press this capture button, it'll store whatever reading it has and analyze it and tell me whether that's pass or fail. Oh, now we're doing the REM test. Okay, so follow the instruction, remain in the RF10 output test screen. disconnect all the leads. So that's easy to do. We'll take these, put them in a nice orderly bundle, make sure they're all twisted. And okay, then we go to connect the double banana REM test cable. So it was important to note that we did say double because in this kit, there is a single banana REM cable. We don't want to use that one. But again, because we're using the double banana, and I think, we'll try it. We'll see what happens. I think because we're in the special test mode, it doesn't matter whether we have the pin or not. So I am purposely going to use the one without the pin just to see if it really does work. Now in clinical mode, this cable would not work. But we're not in clinical mode, we're in test mode. We're just checking the resistance. Set RF output for pure mono 1 at 1 watt power. So follow our instructions. Pure mono 1 watt. Now it doesn't tell me to do it, connect anything to the active. Touch the activate, then touch the deactivate, no hold. Okay, so activate, deactivate, no hold. Now what we'll see is that the indicator went green because we're not worried about the pin. We're just testing the resistance measurement function. And the 2350 is set to 100 ohms. And now I can't go in here and change this again because this is an auto sequence, this is locked. So I can't change the setting, but at least it's telling me what it is. So verify that the REM indicator is green. So verify the FT10 displayed REM Z is between 93 and 170 ohms. So this is the reading here, and it should be 93 to 107. I don't know if you can see it on your screen, but it's 98.9, 99.0. So we're good. So in this case, we'll say that passed. We'll move on to the next. Verify the REM indicator is green. Yes, it is still green. Verify the FT10 REM Z is measurement 43 to 57 ohms. In this case, it's 49.8. So I'm going to go ahead and say that's good. REM indicator should turn red. So we've changed to 0 ohms. Again, that's saying that I put in a cable that's shorted. Covidien is saying you have to use a split pad. Split pads can't have 0 ohms. And in this case, it measuring that short, that 0 ohms, is we're getting 0.6, 0.7 ohms. So that's good. Thank you very much. Disconnect the REM cable. I can do that from the generator, from the FT10. And it says my ZMAG. Now, the important thing is there, I could probably get it something similar. So right now it's 7,000. If I disconnect it from the 2350, that's why it says to do it from here, I get 5,000, 6,000. But there is capacitance in that cable. And so if they're measuring that, now I get 6,800, 7,000. So it does make a difference which end you unplug. So you want to make sure to unplug it from the FT10. In this case, it just says greater than 2,000 ohms. Again, based on the service manual. And so that's good. Connect, okay, setup for output test. And yes, connect the REM cable. Yellow test lead. Now let's see how well I tangled these. I didn't do a very good job. I'll have to try harder next time. Okay. Mono 2. And we want pure 300 watts. So in this case, we're doing, if you think about the settings here, the energy channel is mono 2. So we're telling it to put out here, but we also said connect to here. So this is the cross coupling test. So this is actually a safety issue. They're activating this output, but what happens if, how much energy could accidentally come out this port that is the unintended port? And so that's a very real concern. And so we have to test that and make sure that that is under a limit specified by Covidien. Now they've done the analysis, they've done all the testing, and so you know they know what this should be. So 37 is acceptable. So in this case, now connect to to the left hand of monopolar 1. So we're staying in monopolar 1. We did pure, and now we're going to do spray. And my guess is it's going to be max power. Yep, 120 watts. So what's the maximum worst case output here? How much do I accidentally get out of the port I'm not supposed to be using? And in this case, we have 40 milliamps. And we capture that. It says it's good. Now we're going to do bipolar. So we're still measuring out here, but we're going to tell it do a bipolar output. If I can push the button, right? Bipolar macro. That's important. Max power. Now I'm activating bipolar and I'm measuring off a monopolar. Activate. It's pretty good. We got absolutely nothing. Oh, got to capture that. Absolutely nothing. That's a pass. Set up the FT10 BPR cut. We're going to do another output. Bipolar resection cut. Max power. So it's activating this output. We're measuring over there. What's our cross coupling in this case? We're going to say 4 milliamps. 4 is a good number. It all goes back to 4. Then we go to monopolar 1. Going to pure cut, maximum power. We're still in cross coupling. So since we're activating monopolar 1, we're probably connecting the monopolar 2. So that's some of the keywords as you run through this to help you make sure you've got the thing set up right. You see the cross coupling at the top. We're activating monopolar 1. So if we're activating monopolar 1 and we're doing cross coupling, we can't be connected to monopolar 1. So meter. Don't really show my meter. Now it shows the meter. Thank you. It was taking a break or something, I guess. Sometimes the electrons go slow through the network. Okay, so we got our measurement, 44 milliamps, and we're good. Now we're going to stay connected to monopolar 2, and we're going to do, we did pure, now we do spray. Both waveforms, worst case scenario, maximum wattage. And show meter. We're still activating monopolar 1, connected to monopolar 2. I always like to double check that every time. I always also like to press the capture button every time. That helps. Okay, so now we're moving on. We're still measuring on monopolar 2, but we're activating bipolar macro. Max power. How much energy comes out the wrong port? Let's find out. Very little. That was the same thing with monopolar 1, so that's a good thing. Now, as you run these and you get used to this, you'll see, if you get something that's, 50 million, even if the limit is, even if the limit is 100 milliamps, if you get something that's not, really low, you might want to question something's going wrong with that generator. BPR cut. Ligature. Energy channel is ligature. Yep. So now we're still connected to monopolar 2. And we do our measurement, activation, capture, deactivate. Go to pure. Energy channel, mono 1. So now we're going to the left hand of bipolar. So now we're going to say how much energy comes out of the bipolar port when monopolar 1 is activated at maximum power. Okay. Show meter, activate, capture. And that was pure cut. Next is spray. You'll see there's a pattern here. Pure, spray, max power. The The important thing is to make sure we get the sequence right. Capture, then deactivate, then next. Then measure, then do our settings. CPR cut. It always helps if you talk to yourself as you do this too. Effect 6, activate. Okay. Spray on monopolar 2. 2. And we're still connected to, oh, now we got to go to ligature. So now we're activating monopolar 2. How much is coming out the ligature port? Yes, I really do want you to activate. Okay. Now we're going to go to pure. And I'm pretty sure it's full power, 300 watts. This time it says monopolar 1. Mono 1. Left time ligature. Right time. Oh, I probably didn't do the last one right either. Got to read all the instructions. Connect the blue cable from the right tine of ligature to the rem. Okay. Then we hit show meter. And we'll capture that. Now in this case, since I believe I had an error in this one, I can go back, look at my instructions, and it does say the blue lead to the right. So I can redo this one, get a new capture, because it says spray. We'll use this as a good example. Here's what happens if you realize you made a mistake. You can go back and redo it. There we go. Now we're doing it the right way for the instructions. So we already did this one, so it still remembered that. Now we can move on to the next one. Bipolar FX. See, it wouldn't be any good if I just did everything perfect all the way through. You wouldn't see a real test. That's what I'm trying to show you. Bipolar FX macro. Energy channel is bipolar, power setting 95 watts. And we're still connected to ligature, left and right. So we'll do that. Activate, capture. Remain in the test mode, disconnect all leads. We can do that. Again, we'll try and tangle them all up by putting them in a bundle. See how well we can do that. Set up the FT mono 120 watts. So if we look at the title here, leakage. So that kind of gives us a hint of where we're headed. So now we're doing leakage testing. Oh, I tangled them pretty good this time. Even dropped one on the ground. So we're going to do leakage testing. So we're doing monopolar 1. Okay. To the left tine. Now this is where it gets a little tricky again because it doesn't do automated switching. So monopolar 1, this is through the UFP adapter. It's funny, I didn't have to worry about remembering that part number. It's everywhere through the auto sequence. So alligator clamp between the green. So on the back of the generator, I have this connected to an alligator clamp. It does come with the accessory kit. And that's on the ground lug on the back of the generator for the service manual. And then earth ground. Okay, so then it says connect the equipotential lug to the back of the earth ground of the ESU analyzer using the black jumper lead. Connect the dispersive and ground. So that is now we're connecting our test load to earth ground. creating a ground referenced measurement. And this is simulating what happens if somebody touches the output while it's active. Maybe a nurse or doctor accidentally not want that to be very high. So we go in here, maximum output, monopolar 1. We're measuring the earth ground. It's in, you can see here, leakage 1A. We can also look at the test setup, and it says yellow, active, jumper to ground. Good. Followed my instructions properly. I hit activate, and that's either good or bad. In this case, it's good. So then we go to spray, monopolar 2. And connect the test lead from left side of monopolar 2. Now we're going to check that leakage. Worst case scenario, spray, maximum power. They've already determined what the worst case scenario is, so all we have to do is follow their lead. That is in the service manual and the auto sequence. Disconnect the yellow lead, the analyzer. Yeah, now we're doing patient return. So this is the one that got a little squirrely before. Okay, so because of our colors. So we're going to take our, sorry, I'm getting ahead of myself. We're going to follow the instructions. Pure mono 2, 300 watts. Okay, 300 watts. Now we're going to take our dispersive cable. Well, this is why this cable is in the accessory kit, because if we're measuring the current from the return electrode, we need a single connection to go to active. The whole purpose of that cable. Now we got to make use of it. Dispersive cable, FT10, using alligator clamp. We already got that. Still there, green to the back. Connect the black jumper lead, dispersive, earth ground. Got it. Again, if I have any question, if maybe I like pictures better than words, great. And 300 watts, monopolar 2, activate. Yes. And there's our reading. That is our REM leakage to ground. Okay, then we go to blend, max power, both settings. And dispersive. Yep. Show meter. Okay. Next step, Valley Lab mode. You would think that would be at the end, but it's not. It's right before the B for bipolar. Anyway, I digress. Monopolar 2, very good. 200 watts. There we go. Dispersive cable to the active port, still there. Ground lug, still there. Black lead, still there. Our connections are good. Press active, show meter, yes. Activate. Take our measurement. Deactivate. Okay, so soft coag. Really? Now it's getting crabby. Doesn't want to follow my button presses. 120 watts. Monopolar 2, dispersive cable. Okay, so we're checking all of the output ports. We're measuring the leakage from the REM port with all of the different mode activations. The only question is, how many are there? Fulgurate, 120 watts. Dispersive is still connected. Ground is still connected. That was a little higher. Mono 2 spray. Come on. Spray. Max power. Still going through the REM port. And this is the other indicator, leakage 1B. Tells you we're going through the REM capture. All right, return electrode, shared dual spray. That just sounds dangerous. Shared spray dual, sorry. Both mono ports, energy channel. Interesting. I guess both consist of mono 2. Dispersive lead is connected, alligator green. There we go. We have shared leakage. Cardioblate mono. That was down here. Yep. Cardioblate mono. C's all the way at the end. 100 watts. And dispersive still. Green. So if you actually follow the procedure in the service manual, it's not as convenient with these connections. So we actually rearranged the steps to minimize the number of connect and reconnect and move connections, that sort of thing. We tried to make it as straightforward as possible. Now we're doing bipolar leakage. So main disconnect the REM lead. Okay, we can do that. Tangle our wire with an easy reach, and we'll pick up the one I dropped earlier. All right, yellow test lead from the left tine. So one on the left, 2 active. Okay, using an alligator clamp. Same ground connection as before. We can go back into our show meter. Yep, cut coag bipolar. We're doing bipolar now. And we can activate the generator, cardioblate. Double check one last time. Nope, we want bipolar FX macro. FX macro at 95 watts. Double check our settings. Double check our connections, yellow to left. Yep, we're good. Activate. We're getting closer, folks. 63 out of 75. Like an all-time high score. Bipolar FX macro. Passed it, didn't I? I was already there. Oh, yeah. So we did the left tine 4. Now we have to do the right tine. So we move this over to the right. We're measuring both output ports of bipolar. Activate. And they are a little different. That's why we test them both. Now we go to ligature, which should be, oh, I went the wrong way. I had a 50-50 chance. Wrong 90% of the time. I'm not sure how that works. Maximum power. Yep, this one goes to 350. And now we're going to go to the yellow test lead to the left tine of bipolar. Can do that. And same alligator clip to ground. Same black jumper. Same activation. Same capture. It's the same thing. And it's good. We move on. Ligature BPR. It caught me again. I saw the first ligature mode. I thought that was ligature BPR. The channel is ligature BPR, which is selected, and the output mode is ligature. These things get confusing after 65 steps. Yellow test lead to the right. Okay, so now we're on the right side. We hit the show meter, activate. Yep, that's good. And now BPR coag. Yes, the B's are down at the bottom. BPR coag. We'll make sure we get the right setting, 6, the right port. Yellow test lead to the left tine. Go back to the left. Show meter. 22. That's good. And now we're going to go to the right tine. Coag, effect 6. That's the same. Okay. And then we go to BPR cut. So we did coag. Now we'll do cut. Maximum output. So this is one where we could have optimized a little better because I've been going left to right every meeting, every reading, but that's okay. Now we're going to go to the right tine. Same mode, same port, same output. Just on the right tine. Activate. Capture. Go on to the next. Now we set up for cardioblate bipolar. Left tine, ligature, there's a pattern here. Maximum setting, 100 watts. Show meter. We got a nice little different beep town, 26. I'm so used to the forced triad and the constant tones that those little beeps are foreign to me. Go to the right tine of the FT10. Connections are the same otherwise. Settings are the same. Yeah, settings are the same. Activate. Capture. Gonna make sure it stabilizes. Okay, so now we've done all of the testing that we can do with the 2350. So we can disconnect this lead. We can disconnect these leads. And now we can get into the fun stuff. So what you may not have noticed, well, I'm pretty sure you didn't notice, is that I have a ESU SA 2010 S in this case connected. The the FT10 has been connected through this guy the whole time. So this allows me to do my low frequency leakage testing. Nice if I can get these cords out of the way so you don't have to stare at those. But in any case, the 2350 does all the high frequency stuff, power measurements, but it can't do the low frequency measurements, 60 hertz safety testing. So it mentions a BC Biomedical SA 2005. The reason we need that is for the lead isolation test, which we'll be doing in a little bit. But so you can use the 2005, the 2010, or the 2010S. The S has the built-in safety or patient simulator, so it can do ECG simulations for other things. Slight little plug for the 2010S. But in this case, it's telling us exactly what to do. Plug the generator into the receptacle. Make sure the hot and neutral are closed. The connections are closed. So now the device is on. Set the safety analyzer to measure enclosure leakage. Enclosure leakage. I don't know how well that's visible on the screen there. I'll try and, I don't know. Okay, enclosure leakage. And then use the chassis cable to measure between each of the output receptacles, including patient return. So in this case, what we're going to do is find the highest current that we can find. We'll just connect to all of these guys one at a time. And measurement. And so our instructions here are verify that under normal conditions, under normal conditions that we have 10 microamps, under 10 microamps, and under single fault, we have under 50 microamps. So in this case, yeah, I don't know. I guess you can kind of see the red there. But under normal conditions is hot closed, neutral closed, ground closed, polarity forward. The single fault conditions, say it's an open ground. Oh, there we go, 2 microamps. So that's still well underneath our 50. But so what we would do is go to each of these output ports on the FT10, look for single fault, look for regular. If anything is over that limit, well, then it fails. So now, again, the 2350 can't do this measurement, so it can't collect anything other than me saying, yes, I did this, and it either passed or it failed. So I'm going to say it passed because the highest current we had was 2 microamps or 5 microamps, well under the limit. And then I move on. So the chassis leakage. So measure the chassis earth leakage. So plug the generator into the receptacle, set the receptacle to measure enclosure leakage, which we still are. Connect the safety analyzer chassis cable to the generator chassis. Now, what we had here is that green wire that went back to the chassis, ground lug, enclosure. So connect that up. So normal conditions, here we have here. I create an abnormal condition. Oh, there we go, 88 microamps. So if ground gets open, that's how much current flows through the circuit. So 88 is under 1,000, but we're still good. Okay, so I'll say, yep, you're good. The next to last step. I feel like I should slow down here a little bit because we're getting near the end and then it'll all be over. Okay, so the sink current. So what this is, how much current can flow into the generator under a fault condition. So what we have to do is have a current source. In this case, we go to lead isolation, and I'll go back to my regular lead here. Get these guys to cooperate. So I got a good tangle going. So we connect our leads together, and now, no, I don't want it there. Sorry. I'll disconnect the chassis cable for now. So we'll go to our lead isolation test. So in this case, we're using that as our patient lead. Oh, you can't see that. So I'm connected to the right arm output, and I'm going to go to lead isolation. Now I have to tell it which lead do I want to test. So on this button over here, I selected, and yes, now we can see the right arm. That's the right arm. Now when I press this isolation test, it's going to apply 110% of line current flowing into the safety analyzer to this pin and measure how much current flows through there to ground. So I do that, 15 microamps. So follow the instructions here. I didn't show all the instructions. Connect to lead 1, select lead 1, press ISO test, verify the leakage current is less than 50 microamps. So we are. And then it says repeat for all output receptacles, every single one. Check them all. We'll pretend like we checked them all, and they are all under 50 microamps. It is safe. Now, the ground bond testing in the service manual at the manufacturing facility, typically ground bond testing is done at 25 amps, and it can be fairly destructive. But the safety analyzer here can conveniently measure the earth resistance. So I'm going to connect this to our ground lug on the back. And we can measure earth resistance here and 0.23 ohms. So yeah, specifications are 0.3 ohms using a Covidien supplied power cord, or 0.2 ohms connected directly to the middle pin of the inlet receptacle on the back. So in this case, it's good, under 0.3. And there we go. Now we're done. We completed our entire auto sequence. We fulfilled the PM procedure, and we want to save our results. So let's say that I forgot my flash drive or I can't find it. I don't know where it is. So I can save the results directly on the 2350. So I'm going to call this FT10 test. Let's give it call it St. Patty's test 2022. And then I can enter, and now I can save that. Thank you. It'll be a PDF. Now I can either save the summary or I can save the details. And the details gives you all the information of the test, everything that happened. The summary just saves the first page. So let's say that I'll go in here. I'm going to call this details, and we'll save that. Save details. So you'll see that this one takes a little bit longer to do, but that's okay. What I want to show you is how to get those files off of there if I forgot, either I forgot to plug in my flash drive or I didn't have it with me. But while that's saving, I'm going to share my screen and show you what these results look like. If I can manage to find, yes. Okay, so I should be sharing the Edge screen now. That's the home page for BC Group. Let's look at, this is the summary screen. Okay, so what we see here is I didn't put in the information, manufacturer, model, tested by. I can write that in manually. It shows me all the statuses, whether it passed or failed, what measurements, if there was a measurement taken, what were the measurements, that sort of thing, all the way through for all the steps. That's the summary test. If I want to see the details, this is one that I ran yesterday. It does tell me the serial number of the unit that was used for the testing. For tracking purposes, it tells me when the calibration was due, what was the date of the test. This was my practice run yesterday. So this is the same information. The first two pages are identical. And then we get into all of the details. It tells me exactly what was done throughout the whole test. When we get into all these test limits, all the measurement steps, it'll actually show me what was the load setting, what were the limits, and then what was the measurement that I got. So that's pretty useful there. And let's go back to, oh, it's almost done saving. So I don't know if I mentioned it, but the save full test does take a few seconds. Now I'm going to plug in my USB drive. The real question is, how many times am I going to plug this in the wrong way? Oh, there's one. It's always three, right? Oh, no, I got on the second try. That usually never happens. Okay, so it's almost done saving, and I didn't have the flash drive in there when I did the test. So what we're going to see is, how can I get my test results? Well, if I'm on the network like I am now, I can browse to it through my computer. But let's just say you're not on the network. We find that a lot of networks are locked down by the IT department. So we can't get through there. It's almost done saving. Forgot how many pages it was, but there's quite a few pages. Yeah, 46. It's a 46-page test that it's saving. Okay, so now it's done. I can either go back and do the next DUT. If I have lots of these to test, just do one after the other, or I can go back to the main menu. Yep, exit. Thank you. Now, I saved my test, but I didn't have my flash drive at the time. So I can go into my system tools and I can go to transfer files conveniently right here on the first page. And this top window is going to show me the 2350. So I can go into my data page. There's lots of load curves on here. Somebody's been doing load curves. And at the bottom shows me where I want to go. In this case, the D drive. So every time you plug in a flash drive, it'll just increment that drive letter. C is the internal drive, and then D is the first drive you plug in. So here's my FT10 details and FT. So that's all I got to do, and now yeah, I pressed the button too many times, and that's that. Now my auto sequence is saved. I've transferred it to my flash drive, and I have my complete report ready to go. So I think that's everything. We've reached the end of the PM procedure. Are there any questions? It's hard for me to hear you. I can read you on the chat, but if there's any questions, I'll be happy to take them. If this will be recorded. We're going to share it with everybody, whoever wants to follow up. If you had a hard time sleeping, this would be a great video. Put you right to sleep. No, really. If you have any questions, I'm always happy to help. I like to answer questions. So yeah, if there's nothing else, I guess I'll end the recording here and we'll go from there. All right. Well, thank you all very much. I hope you enjoy the rest of your meeting. And yeah, take care. Have a great weekend. Happy St. Patrick's Day. There we go. Good way to end the meeting. All right. Take care, everybody. Bye bye.